So quick review, I noticed there's 4 or 5 of you that just arrived in the room, so we'll go ahead and recap what we said before about these things. I am currently one-handed because I've recently undergone shoulder surgery, so the warning I gave the group that's already here is if you hear me talking in a sort of strangely unnatural sounding cadence, it's probably because I'm talking to a dictation machine. Especially when we get into the section on timing, I'm going to be putting words on the screen by talking into a dictation engine. So if any of you, if I start repeating words or if you hear me talking sort of strangely, then bear with me here. Okay, so here are today's topics. We're going to talk about equations with absolute values. A lot of you have been posting questions about these things, both in the study hall question engine and also in the forums. And a lot of you have been getting into issues they are issues with the absolute value with these regions and such, but they're issues that it turns out are much too complicated for solving these kinds of things on the GMAT. So we're going to start with a review of the most basic possible facts with absolute value equations. And then we're going to look at how to simplify your life if you encounter such an equation on the test. After that, we're going to have a discussion of timing. This is also a very popular question that people have asked. We're going to start our discussion of timing around the quant section. We're going to shift over to the verbal after that, and then we're going to relate it to the adaptive algorithm. Because we get a lot of questions in the forum, and we get a lot of questions in the study hall engine about, there's a couple of types of questions. I mean, there's timing questions, and there are questions about the inner workings of the adaptive algorithm. And the upshot is that only some of that is really relevant to you as a student. Other parts of it are not so relevant. So what we're going to talk about in the second half of the study hall is we're going to review some facts that we know about the adaptive algorithm, but we're going to review them with an eye to what good is this for me to know this? Like, how can I benefit from solving this sort of thing? And then depending on how we're doing at the end of the time, if we do wind up with extra time at the end, there will be some time to take questions if we have extra time. So everybody give me the smiley face icon. The smiley face icon's over there if you guys are ready to dive in here. Okay, let's talk about it. So we're going to start out with absolute value equations, and we're going to discuss these with a very basic eye at first, and then we'll go from there. So we're going to start with the basics. The most basic absolute value equation that you can really have is something like this. Okay, the absolute value of x is equal to 3. This is something to which you should definitely memorize the solution. Go ahead and indicate in the text box, this should be reviewed, but just to make sure we're on the same page. Go ahead and indicate in the text box, please, what is the solution to this equation. Okay, right. A couple of you are typing in, a few of you are well on your way. Right. The solution to this equation is either x equal to 3 or x equal to -3. So this is very basic. There are ways to reason this out algebraically, but this is the sort of thing that you should memorize. I noticed that somebody in here is moving boxes around on the screen and typing and stuff like that. Whoever's doing that, please don't do it. Thanks. So you should memorize this. This is very basic, but this is the starting point for a lot of discussion that is surprisingly not so basic. So now let's think about this. Absolute value of x equal to y. Solution to that. Go ahead and indicate in your text box. see what people type. We've got a few answers in there. I'll wait till we get a couple of other answers. Yeah, most of you are on the right track. Now, a couple of you are typing stuff about signs in there, and none of you are incorrect. Here's the complete solution to this. All right, if you've got this equation, again, as was the case with the other equation, there are only two ways to solve this thing. One of those is x equals y, and the other one is x equals negative y. So, pardon the delay real quickly. Okay. The only possible solutions here are these. Now, there's a side story here. The side story here is that there are sign restrictions on this, and there are a couple of you typing in the text box who recognize this fact. Okay, in particular, here are the sign restrictions. And these are the sign restrictions that cause lots of pain for students when they're trying to solve these equations. Okay, because if you think about this, these are the two solutions, but there are certain conditions under which these solutions work, and there are certain conditions under which they don't. So, let's think about when that happens. Well, if x equals y, then, y has to equal an absolute value. So, they both have to be positive. And in fact, to be completely accurate, we shouldn't really say positive. We should say that they are both non-negative. And then also, x is non-positive, and y is non-negative would be the most complete way to say this. That's a better way to do it. Okay, so everybody give me a smiley face if you understand this stuff. I mean, give me the other face if you don't. There's another face next to the smiley face if you're confused. Okay, now, the questions that we get about these absolute value things on the forums and on the study hall overwhelmingly tend to revolve around this sort of stuff. Because as you can imagine, I mean, right now this is just x and this is just y. So as long as these are just x and y, this issue is not terribly complicated. But as soon as you start throwing quantities on both sides of the equation, especially if those quantities both involve the same variable, then this issue gets really complicated really quickly. So the question to ask is this. If we actually have to solve this equation, in other words, this equation that's right there, if we're presented with this equation, do we have to consider things like the sign of each of the numbers? Or is it enough just to set up a couple of algebra equations and go to town? What do you guys think? Text box, when you solve these equations, if you think you have to think about the blue stuff, give me a yes in the text box. And if you think you don't, then give me a no. So most of you are giving me yeses. Let me tell you what the real answer is. The real answer is not really yes, and it's not totally no either. The real answer to that question is you don't explicitly have to think about signs, but there's a compensatory step that you have to do at the end to make up for the fact that this sign issue is around. So the complete answer, colon, no caps on, you actually don't explicitly have to think about signs, all caps, but there's an extra step at the end of the process. That, again, was the dictation machine that I've been speaking so lovingly about. So when I repeat words a lot of the time, it's because I'm talking into this dictation engine. So thanks for your patience. Let's talk about what this is. Here's a completely general equation. Notice that this equation is essentially the same thing as what we just saw. And this equation is sort of another version of it. So if we revisit that same page, let's go ahead and add that equation into the mix. You could be dealing with the equation that's already up there, or you could be dealing with an equation that's got an absolute value on both sides of it, such as this. Okay. If you have this, the two solutions are still the same, but now the signs are different. So in the gray type, we'll put the new conditions on the signs. For the gray equation, the two can have any signs whatsoever. The two can have any signs whatsoever. Also for the other equation. So notice that there's a color matching here on the screen. The black facts are true for the black equation, and the gray facts are true for the gray equation. Because in this equation here, it doesn't matter whether these quantities are positive or negative, because when we stick a negative number into either of these bars, it becomes positive. So unlike on the left, the signs on the right actually become immaterial to the solution. So again, smiley faces if you guys are following this discussion so far. Because let me give you the executive summary of what's going to come. Basically this, which gets a little bit complicated and tedious, this is the logic that underlies the shortcuts that we're going to give you in a moment. But it turns out that fortunately enough, you actually don't have to think about this stuff as you use those shortcuts. But this is the stuff that justifies those shortcuts. So let's move on to these. This is a much more general form of what we're looking at. If you get any equation that has the following form, okay, and these will probably look familiar to some of you from your study hall question submissions, because a lot of you posted questions based on equations that look just like these. All right. These have the same form as the equations on the last page. But here's the shortcut that we've been waiting for. Remember that there are only two possibilities for the solution, if there's a solution at all. The only way this can happen, as you saw on the previous page, is either the quantities are the same or the quantities are opposites. So again, in words, the quantities are the same or the quantities are opposites. This is the only way that this solution can be solved. Now remember that you're not concerned with theory. We don't so much care about theory, semicolon. We only care about finding the solutions to the equation. So whatever it takes to find the solutions is really all we're after. Because remember, we're not mathematicians here, we're GMAT test takers. So this stuff over here on the previous slide, this is theory. All this stuff about signs, whatever. But if there's a practical solution that is shorter, then you don't need to bother with the theory. So given that, it turns out that this is all we need to do with a couple of caveats. So we're going to look at an example on the next page. But the conditions of signs under which these happen can be rather complicated. But it turns out that you don't have to think about them when you solve the equation. Right? In other words, you don't have to do a lot of what you guys have been talking about on the forums and so on and so forth. In other words, you don't have to think about regions or segregate the number line according to signs. Fortunately, it's much simpler than that, and a lot of the posts on the forum that we've seen regarding this and a lot of the agonized queries that we've gotten for the study hall are based on approaches that are basically just overly complicated. So let's finally look at a concrete example. So this is similar to a couple of examples that you guys have been posting. All right, let's take a look at this concrete example and see what we can do to solve it. Remember that there are only two possibilities here. So this equation has one of those forms. This equation has the form, I've switched this around a little bit. But, the left and right sides of an equation are not distinct. You could write this the other way if you wanted to. So you could just switch these two sides around. You could put absolute value 2x minus 1 equals find x minus 4. As it turns out, here's all you have to do to solve this. All we have to do is set up the following two equations. Either we write quantity 1 equals quantity 2, which would indicate the two quantities are the same, or we can write quantity 1 equals opposite of quantity 2. Notice that distributing, you're going to have to put the negative sign in front of the entire quantity, thus indicating the two quantities are opposites. So in the text box, let's look at what these equations are. In the text box, what is the actual equation corresponding to this for that equation? Like, what is quantity 1 equals quantity 2 here? Don't solve it yet. Just type out what the equation is. 2x minus 1 is one side of the equation. A couple of you are typing that. What's the whole equation? The whole equation is, you keep the 5x minus 4, and it's equal to 2x minus 1. Then, in the text box, what's the other equation? Yep. A couple of you guys are starting to write it. You just stick a negative sign in front of one of the quantities. And in fact, turns out it doesn't even matter which quantity. So just to be sure, stick a negative sign in front of, all caps, one of the quantities. Doesn't matter which. So in this case, in the example I wrote, you can put it in front of the one on the right. But you could just as well put it in front of the one on the left. So let's go ahead and do that. Or you could just write negative quantity, the other quantity. Again, pardon the slow typing. I'm doing this with one hand. So, or you could write it that way. So everybody that's been writing stuff into the text box is basically correct. Now the question is, what do we do? Because the thing is, you don't just solve these and call it a day. Because you can't. Because there still are restrictions, okay? So you can't just write these and solve them and smile and be done. Because after all, if you go back to the theory that generated this particular issue in the first place, there's still an issue. The signs are still problematic here. Some of these solutions will work and some of them won't work. So how do we tell which is which? Well, here's what you do. You could make, I mean, some of you are typing a text box. You could make sure that one of these quantities is positive, and you can worry about regions where this stuff happens or whatever. But you don't even have to think that hard. It turns out that it's easier even than that. It turns out that all you have to do is one extra step versus solving a normal equation. You just have to check the solutions at the end. You don't need to think explicitly about signs. If you are well-grounded enough in this sort of theory, you certainly can. I mean, if thinking about these sorts of signs comes naturally to you, then of course you can do that. But you don't have to. You don't explicitly have to think about signs. Instead, you just, all caps on, plug into the original equation, all caps off. Okay, again, the all caps on and the all caps off are dictation commands. So pardon if that's interrupting the flow of the study hall a little bit. Yeah, all you have to do is actually take the solutions and plug them into the original equation and verify whether or not they work. So let's go through that for this particular equation and then show you an example. So if we solve this top equation, you can subtract 2x from both sides. That'll give you a 3x over here. And then you can add 3. You can add 4. That'll give you 3. So x would equal 1. This one, either one of these, if you solve, it turns out it's going to be the same thing. So this is going to be 7x after you add that 5x over there. This is already positive 4, so after you add the 1, it's 5. And so it turns out that x is 5/7. So it's any of the 4 possibilities can work. They might be both solutions. They might neither be solutions, or one of them is and one of them is not. It totally depends. So all you've really got to do is try it and see what happens. That's the simpler approach here. So let's take this one and see if that works. Remember, the original equation is that thing up there. I'll get to the text box question in a second. So if we try that, let's just try that and see where it goes. If you plug 1 in there, then you get an equation that says 1 equals the absolute value of 1. This works. So that's a solution. If you take the other solution and give it a shot, then let's try it. If you try that one, again, in the original equation, you definitely don't want to plug these things anywhere but the original. As soon as you transmogrified the equation in any sort of way at all, then it's not acceptable to plug into it. Make sure you guys know that. So if we try this one, 5x minus 4 is 20 over 7 minus 28 over 7. That's negative 8 over 7 equals, and then the right-hand side is 10 over 7 minus 1. 5x minus 4. I made a mistake. This is 25 over 7 minus 28 over 7. And then the other side of the equation is equal to the absolute value of 10 over 7 minus 1. So notice this doesn't work. This is wrong. What that means is just that this is not a solution. It means that what this basically is, it's like you're casting a commercial fishing net that will catch fish that you want, but it will also catch flotsam and jellyfish and things that you don't want. So, but you will get all of the solutions that you want. This is what's nice about it. Like you will get fake solutions, Like this is an example of fake solution. There's a word for that. It's the formal word for that is extraneous solution, but it's all good. I mean, you're going to get fake solutions, but the much more important part of this is you will not miss real solutions. So we don't care. I mean, we can catch all this stuff out of the sea we want that's not fish. We can just throw it back. As long as we're catching fish, we're good. Same sort of thing. You can get all the extraneous solutions in the world. You just throw them. Just make sure to throw them away when you're done. So it turns out the only solution to this equation is x equals 1. And notice that you don't need any reference to signs or regions of the number line or any of that sort of noise when you solve this stuff. Any questions about this? Okay, it looks like no questions. Everybody give me a smiley if you, oh, okay, everyone has a question. All 4 solutions, I didn't say 4 solutions. I said there are possibilities. There are 4 possibilities, which are, the first possibility is that both of these will work. The second possibility is that neither one will work. The third possibility is that this will work and that won't. And the fourth possibility is that this won't work and that will. You can design equations where any or all of those things happen. So it's some of you, I mean, okay, a lot of people studying for this test very much like things like rules and patterns and stuff like that. And I mean, there are patterns to which things will solve the equation and which things won't, but they're not worth memorizing. Instead, because it's so simple to just plug back into the equation. So you're better off just solving these guys and plugging them back in. And I mean, the question in the text box is, should we need to check all the time? This is written down here in big red capital letters for a reason. When you solve them, you will a lot of the time you will get fake solutions. In fact, most of the time you will. It actually takes a pretty concerted effort actually to design a problem like this that doesn't have fake solutions. It can be done, but it's hard. Okay, everybody give me a smiley face if you understand the gist of what we're doing here. And I bet a lot of you probably have a big weight lifted off your shoulders when it comes to absolute value. Okay, now let's look at a couple more things involving absolute value before we shift our equation to timing. So how about this? Why don't you guys tell me in the text box, if you think this looks harder than what you just did, then write harder in the text box. If you think this looks easier than what you just did, type easier in the text box. So like we got a split decision here. Some of you are saying that it's harder, some of you are saying it's easier, some of you are saying it's not the same level of difficulty. I got good news for you guys. The good news is this is actually easier than the previous problem. Let me tell you why. We'll go back to the theory page real quick, and I'll tell you why that is. Here's the theory page. Remember that if you write this, the signs turn out that they don't even matter anymore, because you've got 2 absolute values. And so these absolute values will come out as positive regardless of what's going on with the numbers. So if x can be either positive or negative, and y can be either positive or negative, and this is automatically going to work out. It's kind of nice. So if you go back to this guy, it's got that form. Again, this form, when you solve it, the procedure for solving this form is not fundamentally different from the procedure for solving the other form. The procedure for solving this one is the same. You still just write this, and you solve them. There's a difference at the end, which we'll get to. All right. And here's what that difference is. First of all, the equations are the same. Exactly the same equations. Then just to make sure that we have the complete picture of what's going on here, I'll type the other equation that you can also write. You can also write this way for the other one. You can also write the opposite of the first quantity. So recall what the solutions were to these guys. The solution to this thing was x equals 1, and the solution to this thing was x equals 5/7. Now here's the difference. In this case, there are actually not any extra steps, because this is going to work out no matter what. I can guarantee you that both of these will work. I mean, if you go ahead and plug back in anyway, here's what will happen. If you take this one and plug it back in, then you wind up with an equation that says the absolute value of 1 equals the absolute value of 1. That's going to work. But if you look in this case, you can see why it doesn't matter for you to plug back in this time. If you plug in the one that used to be a fake solution, here's what happens this time. What happens this time is you've got -3/7 on the left-hand side and +3/7 on the right-hand side. But since they're both enclosed in absolute value bars, we're fine this time. These are both going to work. If you have this form, you're not going to have any fake solutions at all. This is very nice. We like this. No fake solutions. For this form. All right. Again, we'll put a box around that. You can just go ahead and trust, if you have this form with a double absolute values, then you don't need to check the solutions to the equation. That's kind of nice, huh? Now, for some of you, this is confusing. I mean, remember that it is still not a big effort. It's not much to ask of you to take these numbers and to chug them back into the equation and to watch what happens. So the plan here is you should, if you're 100% sure that you're going to remember one absolute value and one not means you have to plug them back in. 2 absolute values and nothing else means that you don't have to plug them back in. If you're going to remember that absolutely 100%, then remember it and you have a little shortcut. But notice that the shortcut is just saving you maybe 15 seconds in this case. It's saving you however much time you need to just plug a couple of numbers into an equation. So if you are even like 98 or 99% comfortable, you should still just go ahead and plug back in just to make sure that you are on the same page. Okay, but again, this is the kind of equation that people are posting on the forums and posting to the study hall and absolutely agonizing over like regions of the number line. I mean, I'm sure this looks familiar to a couple of you guys because you are the ones who submitted these things. Like a lot of people are like, wow, I need to know when this is positive and this is negative, or when this is negative and this is positive, and this is negative and this is, no, you don't. You actually don't care. All you have to do is just set up this and then go from there. Now, there is, I don't mean to break any hearts or anything like that, but there is one exception to this nice, pretty little shortcut, and that's this. Back to the theory page. There's one time that you cannot get around having to think about this sort of stuff. Does anybody know when that is? Like, there's one time where you really do have to think about this stuff. Let me give you a hint. Notice that these are equations where you solve for a number. When we were writing about x's and y's, we suddenly didn't have this nice friendly little cushion anymore. In the text box, go ahead and see if anybody's seen what I'm getting at here. Okay, I'll give you another like 15 or 20 seconds or so to look at that. Because I'm looking at something else here real quick. Okay, it's not really that. It's when if you got a negative outside the absolute value. One of you said negative outside the absolute value. That's not. Let me just go ahead and put that up in the corner here. If you've got an equation like this, actually, I'll tell you what. I'll make a blank slide and we can actually discuss those real quick. Let's say that you've got, pardon the delay here. We'll do some copying and pasting. That's actually a good question, so just for completeness, I'm going to go ahead and address that. Okay, what about I'm going to edit these, so sit tight real quick. What if you've got a negative outside of one of these absolute value signs? That's actually a good question, so let me edit these. What if you have that, or if you have that? I'll go ahead and just answer this for you guys. If you have this one, this is impossible unless both of these quantities are 0. Because this is an absolute value, which means this is either 0 or above. So again, let's take some small type. This is either 0 or higher. And this thing on the right, since it's a negative of an absolute value, is either 0 or lower. So this is not really going to be much of an issue here. This is only going to have a solution if both of those quantities are 0. So again, this one is only going to work if both quantities are 0. That's, yeah. So what you could do, it's actually kind of interesting though. I've never seen this on the GMAT, but this is actually a sort of rich situation, because if you set up this equation, you can actually mine this for a considerable amount of gold. Like, let's say I give you something like this. If I give you, this actually could wind up yielding a tremendous amount of information. If I give you an equation, let's just make something up like this. Let's say I tell you 3x minus 2 equals the opposite of the absolute value of y squared minus 9. I mean, this would actually be brilliant. Because if they gave you something like that, look at how much information you got. If you've got that much information, then you know that 3x minus 2 has to be 0. And on top of that, you also know that y squared minus 9 has to be 0. I mean, that's a tremendous amount of information. So you know that x has to equal 3/2. And you would also have, from one equation, you've got the value of x, and you've also got 2 possible values for y. I mean, that's actually a pretty amazing result. So, but that's the only situation in which this can occur. And then if you have this, does anybody know? How would you solve an equation that looks like this? This one, it turns out, is not going to be any different from this one. It's going to be the same thing. So let me put that on here, a little cut and paste action. It turns out that this is the same thing as. It turns out that you use the same solution technique that you would use for that one. The only difference is that you're not going to get the same solutions. The solutions that would be fake solutions to this one turn out to be the real solutions of that one, and vice versa. So again, let me dictate this. The difference, the fake solutions of the first one are the, all caps, actual solutions of the second one. And vice versa. But you would still do the same thing. In other words, you would set up the two equations, one of which would say the opposite of this equals this, and one of them would say this equals this. It's the exact same situation. The only difference is that the fake solutions and real solutions would switch places. Okay, that's actually a very good question. I'm glad about that. Product of two absolute values. Somebody asked about it, so I'll go ahead and treat that's a really, really quick treatment. In fact, it's quick enough that the bottom of the screen here will be good enough for it. If you have the product of two absolute values, just combine them into a single absolute value. Because you can do that. In other words, if you have something like this, if you have absolute value of x times absolute value of y, then that's the same as just having the absolute value of xy in the first place. So the product of two absolute values is not something that really exists in the first place. At least you don't have to leave it that way. So good. Okay. Well done. Now let's go back to my original query. What I was asking was there are a handful of situations in which you actually have to consider this sort of sign issue. And let me show you what I had in mind when I was saying that. What I had in mind when I was saying that was problems that are like this one. All caps on. If the problem involves only variables, then you will normally have to treat the signs explicitly. Because here you don't wind up with numbers that you can plug back into the equation. Instead, you wind up with variables that you can't plug them back in because they're variables. So this is a little bit awkward because you definitely do have to think about the signs. On the other hand, the beginning is the same. You can still take this equation and you can separate it into the two component parts. So there are still two separate equations that pertain to this condition. One of those is x equals actually y minus z. And then the other one is x equals all the signs are switched on one side, negative y plus z. Or what you can do is actually switch the sign of x instead of switching the sign of y and z. That'll make your job easier. Because then you just have to know which way x goes. This is only going to be valid if x is 0 or positive. This one is only going to be valid if x is 0 or negative. So again, let me fix that sign. In this case, there's really no getting around that. Everybody follow this. This is a little bit more complicated. Only in the case of variables do you have to do this. But what I want you to notice is that, like, this is literally the entire problem. You know, I mean, it's not like something like this, where, like, with something like this would probably be one statement on a data sufficiency problem. Okay, something like this you would have to solve quickly because it would be one step of some much larger picture. If you look, that's not the case here. Like, if you can successfully resolve this equation into those two parts, then these statements are really not that much of a stretch to use. So let's go ahead and finish this off. If you have statement 1, statement number 1, you can rearrange that into one of these. In particular, you can rearrange it into this one. This rearranges to give. This rearranges to give the equation, the second equation. You can make that into negative x equals y minus z. So is that sufficient to solve the data sufficiency problem, yes or no, in the text box? So no, it's not, because we don't know if this condition is also true. We need to, this by itself is not good enough. This is only valid if x is negative. So, all caps off. This is not good enough. We would also have to verify that x is 0 or negative. We also have to verify pardon the dictation delay. We also have to verify that x is either 0 or a negative number. So that's not going to be sufficient. But then from here, it actually gets much easier. If you have statement 2, this is definitely not good enough by itself. If you have the statements together, then it's exactly what we're looking for. If you have the statements together, then it's this precise condition. So that would be sufficient to solve this problem. So notice the upshot of this, the reason I'm showing you this slide, is the following. If you get an absolute equation with nothing but variables, comma, you may indeed have to consider the signs of the variables. All caps. However, comma, if you have to consider these signs, comma, the problem should become very quick once you successfully resolve the equation. As it did here, like as soon as you did this, it was quite good enough. As far as this question that somebody has put into the text box, what's the source of that? Like, where did you get that from? That okay? That problem is actually sort of, that's one of the problems we're putting on suspension for the pool right now. We're actually investigating whether that problem is too obnoxious for the GMAT. We'll get to it at the end of the session if there's time. But it is one of the problems that's in our, considering it may be too hard, the pool, but we'll get there. Okay, so back to some other stuff about absolute values. If you get this is going to be a 2-minute screen. If you get something like this, it's extremely unlikely that you would. But if you get something like that, then here's what you would have to do. You would actually have to set up all of the possible combinations of quantity 1 and quantity 2. Okay, again, let me repeat my statement from before that this is extremely unlikely. But if you have anything outside the absolute values, then it's not just opposites or equals anymore, because the problem is that the sign of this constant won't change. So, therefore, these are actually all going to be 4 different equations. Again, I would estimate there's basically a 0 chance that you will see something like this, but in case you do, and worse yet, you will also have to check the answers. So this is too obnoxious. I don't really think you would ever see anything along these lines, but who knows? It's possible. But here are some things that you do have to know how to deal with. So these are some basic inequalities that involve absolute values or are closely related to equations involving absolute values. Notice that these two have specific numbers in them. I'm going to go ahead and cover these up for a second. These have specific numbers in them, although I think you can see how these would be generalized. Okay, these are not the 4 and the 16 are not special. You can generalize these examples. I'm just choosing to illustrate with a 4 and a 16 because it's easier than throwing more variables at you. That's basically the idea. So who knows off the top of their head what the solution to this is? If you know, then go ahead and type it in the text box. Most of you probably do, but it's a nice review. Remember, this is inequality. So if anybody knows the solution to this, go ahead and indicate in the text box, please. It's not an equation. All right? A couple of you are typing solutions to the equation. These are greater than. So there's, yeah, this is a 2-part solution. If you wind up with absolute value and greater than, two-part solution, either quantity is greater than 4, or quantity is less than -4. Okay, thinking about a number line may help here, because the absolute value is basically the size or magnitude of something. If you think about where all the numbers are whose magnitudes are bigger than 4, That's where they are. And by the way, this is actually the solution to both of these equations. So if you see an equation with a square, if you see an inequality with a square in it, then it's the same thing. So note, inequalities involving squares are a lot like absolute value inequalities. You should memorize this. Another one that you should know, if you have a less than, what's the solution to this one? Text box. Yeah, okay, you got it in the text box there. In this case, quantity, it's not a two-part solution anymore. It's going to be stuck between a negative value on the one end and a positive value on the other end. Notice that in the case of the 16, it's the square root of whatever this quantity is because this is squared, but it's the same solution. Either one of those two inequalities is identical. Finally, there's this one, which in fact is equivalent to, there's going to be some exponents coming, so be patient. These two inequalities are actually exactly the same. Now in this case, it's a little bit different. You don't really want to make this algebra. Instead, here's what you want to do with this one. This is a little bit different. The best way to express the solution to this is to just rephrase it. Rephrase. The solution to this inequality is basically x is a big number and y is a smaller number. But what don't we know? What's missing from this? Like x and y could have any what? Yeah, well, absolute x, I mean, that's what we have here. Yeah, we don't know the signs. So if you just add on something like this, then that's your rephrase. X is either positive or negative, and it's big. And y is either positive or negative, and it's small. I mean, that's not algebraically formal, but in most cases, you don't need algebraic formality. This is the solution to that. If you see either of these, this is what you should think. If you see x squared is bigger than y squared, realize that these are the same. And also realize that this is what they mean. It means that x is a bigger number than y is, like in terms of size, but that we don't know whether they're positive or negative. All right, smiley face, if these things make sense, you should have all of these guys memorized. Smiley face, if this makes sense. Okay. All right, as for the extra question, tell you what, the person who posed the extra question, let me scroll up and see who that was. Raj, there's no way we're going to get to that in today's study hall because we've actually only got half an hour left. So why don't you either post it on the forum or send me an email with it? How's that? Okay. Let's tell you what, if you do post it on the forum, go ahead and send me an email with the link. That way, since you're here in the study hall, I can prioritize the answer to that. All right, now let's shift topics a little bit. Let's talk about exam timing. And in our discussion of exam timing, there's going to be two central parts of this discussion. The first piece of the discussion is the adaptive algorithm. But the second piece of the discussion is what the adaptive algorithm means for you. All right, now let me give you a stupid analogy here. Here's a stupid analogy. Here's a stupid analogy. Let's say that you're a driver and you're looking at a car that has anti-lock brakes. You may see a brochure that details the inner workings of the anti-lock brake system. But are you really interested in the inner workings of the system? As an average driver, do you really care how the inner workings of the anti-lock brakes function? What do you guys think? And yes, we're going somewhere with this. So, hold on. Okay, no, you really don't care. All that matters in this situation is, all caps on, what this means for the way you drive the car. In other words, I can tell you everything that you would, I can tell you everything you would want to know about how the anti-lock brakes work. But really, all this means is strategy for you as a driver. Okay, like for example, it's the end strategy. So as an example, if any of you know anything about anti-lock brakes, you can go ahead and slam on the brakes rather than pumping them in certain situations. Okay, notice that this is not anything to do with how they work. Okay, this is a pure strategy statement. This is a pure statement of strategy. Okay, here's where we're going with this. I told you we were going to do something with that. The analogy is, no caps on, the adaptive algorithm itself, adaptive, that's going to be analogous to, okay, do you guys all know, give me a smiley face, give me the non-smiley face if you don't know what I mean when I say adaptive algorithm. Is there anybody out here that doesn't know what I'm talking about? Okay, I see one of those faces. The adaptive algorithm is like, let me go ahead and put this in the top corner up there. Adaptive algorithm means how the difficulty levels adjust up and down according to your performance. In other words, this is called a CAT test. The CAT stands for Computer Adaptive Test. The adaptive algorithm refers to, the way that these, if any of you have seen our open houses or the first session of our online course or anything like that, there's these graphs that we draw that look something like this. where we say, here's a student's difficulty, here's a student's ability level, and then we start graphing what the test does. You know, first question is like right here, and you get it right, and you get it right again. Then you get it wrong, then you get it right, then you get it wrong, then you get it right, etc. Okay, so it's that whole thing. It's the whole way that difficulty adjusts according to how you're performing on the test. So give me a smiley face, especially the two of you who gave me the other face before, if you know what I'm talking about. Okay, if you still don't know what I'm talking about, you can give me the other face. All right. So this is, okay, see, a lot of people spend a ton of time worrying about the particulars of this situation. Like, a lot of people are just very much up in arms about this. They're like, tell me about the exact difficulty level of this problem, or tell me about, you know, if I miss a 640 level problem, then what difficulty level will I get next? That stuff, that's the adaptive algorithm itself. Okay. You know, numerical difficulty levels, etc., is like the inner workings of an anti-lock brake system. In other words, all caps on, as a student, you don't really care, no caps on, about that sort of stuff. Okay, this is going to be a very surprising statement to a lot of you out there. Okay, but as a student, you shouldn't really care about the adaptive algorithm itself unless you write exams. Okay, unless you actually write tests, you could not care less about things like numerical difficulty levels or about the actual numbers on the graph like this. Instead, all that really matters is, all caps on, how this information affects your strategy. It's just like the anti-lock brake system. It's a kind of weird, silly analogy, but it's also a good analogy. You know, I can tell you everything you would ever want to know about anti-lock brakes, but as a driver, it doesn't matter. All that matters is when I tell you actual things that you can do when you drive the car, like slam on the brakes. Same thing, I mean, I could tell you about the adaptive algorithm for hours if you really wanted me to, but there's no reason to. Instead, all you really need to know about it, and more to the point, all you really need to worry about is direct effects on your strategy. So with that in mind, let's go ahead and get into an equation of what the adaptive algorithm means for you as a student. Okay, so as a recap of what we just saw on the other slide, the inner workings of the adaptive algorithm really don't matter. All that matters is how your strategy is affected. So let me give you a couple of slides. If any of you, give me a smiley face if you've ever seen either our open house presentations or class 1 of our 9-session course. Okay. So not too many of you, so let me go ahead and, that's about, I think, 6 or 7 smiley faces. Tell you what, more to the point, let me kill that. Okay, more to the point, how many of you have seen this graph? Give me a smiley face if you have seen this graph before. Okay, so that's like half the room. And I do need to reconstruct this here, but it's not going to take me a terribly long time. Okay. So for those of you who haven't seen the graph, again, let me take a brief moment to explain what in the world is going on here. What this is the test adapts to you, right, as you go along. Okay, so what the axes mean on this particular graph is this is difficulty of the problems, and this is progression of the test. So, and I mean, this is not a literal truth. The test is not really an absolute precision instrument that automatically goes up if you get it right and down if you get it wrong. This is a first order approximation. You know, it's not so finely calibrated that it literally responds to every question individually. It's just looking at your overall performance and going from there. Now see, here's the problem. The problem is this, again, is not where your focus should be. This is like, how does an anti-lock brake system work? This is inner workings, and ultimately you don't so much care about this. Instead, what you should care about is the result as far as your strategy goes. In other words, your priority focus what does this mean for my timing and test taking? Let's talk about what this means. Okay, in particular, let's talk about this as it contrasts with paper tests, because I'm sure all of you at some point have taken a paper test. If you were going to graph, so what that blue line corresponds to there, that blue line corresponds to adaptive test. If you take a paper test, and I bet that most of you, give me a smiley face if the vast majority of these kind of things that you've taken in the past have been on paper. Smiley face. Like, not the GMAT, but give me a smiley face if you are used to taking paper tests in your academic history. Okay. Really? Only like half of you guys? Wow, it's a new generation. Okay, well anyway, when you take a paper test, here's the difference. Paper tests look like this. Okay, generally paper tests start out with lots and lots of easy questions. So again, that is a paper test. Notice that you've got this whole region there in the paper test, where these are questions that are way too easy for you. And when you do these questions, what winds up happening is you wind up building up a pool of surplus time. And the higher scoring you are on these paper tests, the bigger the pool of surplus time that you build up. And so if you, of course, if you build up a pool of surplus time, then you have the luxury of being able to waste the surplus time on the most difficult problems. So that's the strategy for a paper test. All right, so on the what this means, so getting away from the mechanics of this and getting into what this means for you as a test taker, let's make a contrast here. All right, in the paper test column, again, we'll review, and then over here we'll talk about adaptive testing. So again, with a paper test, there are lots of factors that change the timing. In particular, caps off, no caps on. You build up a pool of surplus time on an initial bunch of easy problems. So you can usually afford to spend extra time on the hardest problems. This effect is even more pronounced because you can skip around and revisit problems. Notice that none of this is true when you take an adaptive test. Absolutely none of it at all whatsoever. So your timing here, what most people do is they take this sort of attitude and they bring it over to the adaptive test, and the result, frankly, is disastrous. Okay, notice what goes on. Again, when you look at this graph, it's not the graph itself that you're thinking about. It's what does this mean? Notice the first thing that you notice is that there's basically no pool of surplus time. Okay, I mean, you know, because you start out at middling difficulty levels, and it very quickly gets to know you and starts throwing problems at you that are difficulty appropriate. So the biggest deal is you are absolutely not going to have a pool of surplus time. You just won't have one. It's not going to exist. So instead, what this means, all caps on, you must have perfectly consistent time management, no caps on, in order to succeed on this test. It's completely the opposite of what's going on over here. Here you can afford to spend extra time on the hardest problems. Here you absolutely cannot. After a certain amount of time over the average, you must consistently give up and move on to the next problem. This is very easy to say. This is a very easy idea to put forward. It's a very easy idea to understand. On the other hand, this is absolutely not an easy thing to do if you are traditionally a high-scoring test taker. In fact, the higher your beginning score when you take this test, in all likelihood, the more difficult it is going to be for you to do this. Because if you're a high scorer, this may be the first time that you have ever had to do this on a test in your life. And this goes doubly so if you grew up in the United States and you're under age, say, 35 or so. Because if that's the case, then you probably went to school with tests that were not really that hard on average. And so this may be the first time that you've ever really had to do this a lot. Remember, you can't be a perfectionist. So we're gonna talk about what these limits should be on the next slide. But everybody give me the smiley face if you respect these differences between paper tests and adaptive tests. Okay, and in particular, one more difference is this. Notice the way that difficult problems affect the thing here. On a paper test, let me go ahead and move some of this stuff up. Pardon me, I'm just moving things around here. Take about a minute to consolidate this so I can put some more things up here. Okay. The other thing I want you to notice about these things is that here on a paper test, most of the high scorers are going to be getting all of these things right. And so your score is basically going to come down to how you perform on these hardest problems. You know, so on a paper test, the most important problems are the ones that you find most difficult, comma. So you are justified in spending extra time on these problems. Again, not the case here. When you take an adaptive test, it's not like a paper test where you have a giant pool of easy problems and so you have a few all-star problems that are going to make all the difference at the top. This is the thing that's really nice about adaptive tests. When you take paper tests, there's going to be these like 4 hard problems at the end of the section which make all the difference. Like those problems are basically for all the marbles, all the money. On an adaptive test, not the case. Like when you perform well, the problems rise to the occasion. So you're going to be faced with an array of problems that match your performance. So when you look at an adaptive test, the thing that's ironic about an adaptive test is missing problems. If you miss problems that are hard for you, the effect is much smaller than if you miss easier problems. So, all caps on, give up earlier if problems are hard. That's really counterintuitive for a lot of you guys. But most of you who have time management difficulties have those difficulties because you get kind of sucked into the world of really hard problems. And you spend 3, 4, 5 minutes on those problems. And it comes back to bite you. When in reality, you should actually be doing the exact opposite. If a problem, and I mean, again, you don't need a concept of specific difficulty level to do this. Most of you are decent judges of whether a problem is easy or hard. And so if you know a problem is difficult, remember, numbers, you don't care. I mean, 750 problem, 710 problem, who cares? If you know a problem is difficult, then you should be more willing to give up on it if you are stuck. The problem seems to be more basic. Again, your judgment is usually pretty good on these things. If the problem seems to be more basic, it's worth a little bit more extra effort. But let's lay down some concrete guidelines here before the study hall comes to a close. Let's lay down some all caps on, particular timing guidelines. Quant section. Who knows? Probably most of you know. What's the average time for a problem on the quant section? Go ahead and indicate the text box. Yeah, it's almost a perfect 2 minutes. So in the quant section, the average time per problem is 2 minutes. So what do you guys think? In the text box, what do you think would be an appropriate upper limit for each quant problem? Upper limit. In other words, how much time should you allow yourself to complete the problem? Let's see what you got to say. Okay, so notice you guys can see the text box. Notice the diversity of opinions in the text box. We're getting answers all the way from 1 minute 45 seconds to 3 minutes, and some people are saying things like 90 seconds. Okay, guys, this is an average. Okay, what an average means is, of course, that some of the problems are going to take you longer than this, and some of them are going to take you shorter than this. So one thing that should be a pretty immediate consequence here is that you can't use this number as a limit. And you definitely can't use any number smaller than this as a limit. So for those of you guys who are answering things like 90 seconds and 1:45, if you limit yourself to 90 seconds, you're going to have about a half an hour left at the end of the quant section. And you're just going to be sitting there staring at the screen. That's not an effective use of your time. So here's what you should be doing. The people who are saying 3 minutes, you guys are the closest on target here. No caps on. You should have an internal stopwatch. In other words, a good idea of how much time has passed without actually having to look at a timer. When you know that you are starting to get around that didn't dictate correctly. Let me fix that. When you know that you are starting to get around 2:30 to 3 minutes, it's time to quit. This is a good upper limit, okay? You don't want to go with 2 minutes as an upper limit because you will finish some of the problems in less than 2 minutes. Okay, so 2:30 to 3 minutes is a good upper limit. All right, one of you put how in the text box. I'm not sure what that's a response to, so if you could clarify in the text box, that'd be fantastic. But when you get to this 2:30 to 3 minute, okay, that's what I thought you meant. How do you train an internal clock? Well, let's talk about how you do that. The way to train your internal clock is you just train it while you're doing practice problems. So as you do practice problems, time each problem keep the timer hidden from view as you work. See if you can guess how long you took, and then calibrate accordingly. Calibrate. By calibrate, you mean you just adjust your estimates up or down. And this is how, like, if you're a long-distance runner, you have to be able to know what pace you're running at. This is the same sort of thing. The way that runners train that is they just run lap after lap after lap, and they just compare that pace with the stopwatch until they start learning after a while how long it takes. This is the same thing. You don't look at the timer, and then at the end of the problem, before you look at it, you say, okay, I think that was about 2.5. And then if you turn the timer over and it says 3:45, you know you've got issues, and you know you have to calibrate your estimates down accordingly. Similarly, if you turn it over and it's half the time you thought it was, then you've got issues the other way. So it's really just repeated trial and error. It's not a real fancy procedure or something like that. Okay, and then this is what you do. You've really got to have an ability to do this without looking at the timer, because you can't afford to keep looking at the timer during the test. If you do, it'll up your stress levels big time. And it'll also make you waste a lot of time thinking about subtraction and division and figuring out how much time is left and all this other thing. A couple of other guidelines. If you have no clue how to solve a problem, then guess early. This is also really important because, I mean, remember that you're going to allow yourself over the average to do some of these problems. Okay, now you know how averages work. If you're taking this test, you better know how averages work. The way averages work is if you have some quantities that are higher than the average, then you also have to have quantities that are lower than the average. What this means is that if you spend this much time solving a problem, you're going to have to correspondingly solve some problems in less time than the average. There's two ways to do that. First way to do it is to have a problem that you get fairly quickly and you solve and you're done with it. That will occasionally happen. The other way to do it is to get a problem that you have absolutely no idea what is going on. Or you try doing some work and it hits a dead end. If you get something like that, don't stare at the problem for the full 2 minutes or even for the full 3 minutes. Just guess. Let it go. Remember, when you take this test, remember, it's okay to miss problems. This is not a practice test. This is not a paper test on which you have to try to get every single problem right. Because it's adaptive, it becomes a lot more acceptable to miss problems. So that's basically the deal with the quant timing. The quant timing consists of pretty much this trinity of things. There's the internal stopwatch, there's the limit of 2.5 to 3 minutes, and there's being willing to let stuff go. Really, that's all there is to it. Quant time management really boils down to nothing more than respecting these 3 principles. So again, see this question is, I don't know if you guys can see the question, it's in the text box, but it's like this whole, does it change difficulty level based on the pace you are answering? That's the kind of problem whose answered, I mean, the answer is no, it doesn't. The cat doesn't care how long you've taken so far. But that's the kind of question whose answer is frankly useless to you as a student. I mean, that's not the kind of thing that's really going to help you. And the thing is, really, you got to not be worrying about stuff like that. If you are, then it's just distracting you from things that do matter. But the answer to that is no. The test doesn't care how long you took to do it. It'll adapt the same way whether you take 5 seconds or 5 minutes. So there's no, you can't game the test by doing it. All right, so this is pretty much it. We're out of time for today, so I mean, in the next study hall, I'll probably talk a little bit about verbal time management. But quant time management is pretty much these three principles. Have an internal stopwatch, know when it's time to quit, and quit at this time. And by the way, let me leave you with one more thought about this quitting time thing. When you are working problems at home, all caps on, you must still quit at quitting time. No caps on. In other words, do not just acknowledge the quitting time, but keep working. You have to get used to actually, the question was the session recorded? Yes, the session was recorded. It should appear on the Thursday's study hall page by, I think, next Monday or Tuesday at the latest. When you're doing, this is going to be the hardest part. When you're working problems at home, even if it's just practice problems, even if you are not taking a practice test, you still have to quit when it's time to quit. Okay, you can't just say, oh, it's quitting time, but I'm going to keep working on it. Because then the habit that you're building is not quitting. The habit that you're building is continuing to work. Because actions speak much louder than words. So you have to actually practice with the same time management with which you take the test. Okay, yes, it's annoying, yes, it's frustrating, but it's the only way to prepare for this test. Okay, the earlier study hall, there's a page on the Manhattan GMAT website, but I'm not quite sure how to navigate there from the front page, so instead what you can do is you can just go into Google and you can type this. You can type Thursdays with Ron, and the first result that comes up should be that page. So I don't know where the links are on the front page. I actually have no idea. But if you Google this, it'll take you right there. All right, so that's the deal for today. That's it. We're a little bit over, but not by a whole lot. So go ahead and keep submitting questions, and I hope to see you 2 weeks. Remember, the one in 2 weeks is at an earlier time slot. It's going to be on, it's the Eastern time friendly time slot. Check the website for the exact time of that edition. Okay, you guys can quit out of the application directly if you you don't have to do any sort of, the next one is 2 weeks from today. So that's Thursday, March, I want to say March 4th. But it's whatever 2 weeks from today is. You can quit the application. You don't have to do any sort of elaborate log out procedure. All you have to do is just quit. If you don't, then I'll start logging you guys out here in a couple of minutes. Thank you for attending.